This is chapter 21, example 1. So what we have here is a circuit that kind of highlights the usefulness or the main function of items like memory. So what we have here in this chapter is D flip-flops, which is a 1-bit storage element. So this problem is going to use 1-bit storage elements, but what we're looking at in this circuit is what we want is to show the 3 previous values, or the values that were present on a clock edge. What we want to do is show those 3 previous input values on the output. There's enough right there to draw the interface to this circuit. And so it looks like this. We know it has a clock. We know it has an input. And we have 3 outputs. We'll call it V1, V2, and V3. So the issue is that we're only getting 1 input at a time, yet we have to show the previous 3 inputs. Now this is somewhat of a classic circuit, or the solution is somewhat classic. You see it quite a bit in digital design, and you want to look at this thing. So essentially this is taking advantage of the fact that only way I can do this is show the 3 previous values is to store them. In this underlying circuit here, we necessarily need 3 flip-flops. So let's go ahead and draw that. Before I draw this, we'll say that the flip-flops are going to share the same clock signal. Here we are so far in this circuit here, and we've drawn our 3 flip-flops. They all share the same clock signal. Put the interior of these flip-flops, the D and the Q, blah blah blah. But I did not write clock for the rising edge part of this thing. That's generally never written, because when people see a rising edge like that, 99.99% of the time it's for a clock signal. What I'm going to do, I have to store these 3 values. It should be fairly obvious that the first value I'm going to store needs to go into a flip-flop. Okay, it's going to be stored there. The second value, where is it going to get the second value from? The second value is going to come from that first value. So when that clock edge comes around, that is going to take the value that's in this top flip-flop and latch it in to this middle flip-flop. Accordingly, same time, same clock edge, this value from this middle flip-flop is going to be latched in to this lower flip-flop. So this is kind of a bucket brigade of passing the data from one D flip-flop to the next flip-flop. I don't know how you want to describe that. So in the end, these are the 3 outputs right here. And I think I'm done with this circuit. So the issue here is state the types of control in here. What kind of control? I don't see any device in here that has a control input, and so this one is essentially no control. I mean, this would be a really good problem to show a timing diagram for, but I think I'll skip that for now. So we'll have chances to do that later. And so the issue is when this clock edge comes along, it latches the input data into this flip-flop at the same time as this flip-flop latches the first flip-flop's old data. At the same time, this third flip-flop latches the middle flip-flop's data. Interesting little circuit here.